Hi students, in last class we are discussed about how to capture the video and what is the video, and these are the things we are discussed. And especially in this topic we are discussed about how the video is going to be captured and what is the things is there. These are we are learned in yesterday class, and today class we are going to discuss about video transmission. So what is the video transmission? Video signals are transmitted to receivers through a single television channel. So coming to here, we are going to send the video signals through a single television channel. For example, if I am going to be take the one television channel, just like I am going to be taking Gemini TV. So Gemini TV is going to send their programs by taking the video signal. So based on that video signal, it is going to be transmitted, and the receivers is going to be catch the signal, and after that you are able to watch the program. So especially in this transmission, it is going to be depend on color. So it is going to be depend on color. So what is the color? So the color we can call as encode color. So in this it is going to be comes to the a video signal. So here it is going to comes to the a video signal. So video signal comes to the is a composite of three signals. So coming to here, so generally the color encode. So what is the color encode? The color encode is available for us, especially in video. Two colors are available. So first one is the CMYK color, and the second one we can call as RGB color. So CMYK comes to the, just like in this we are not able to get the natural colors, but especially in RGB color. So RGB stands for red, green and blue, and in this red, green and blue, so here it is going to be take the actual image part. So if you want to take the actual image part of the images, so here I am going to be take the RGB color mode. So coming to here, a video signal. So whatever may be the video signal is there is a composite of three signals. So here we are going to be sending the programs using the video signal. So the video signal is going to be sent by taking the three signals. So coming to here, for transmission purpose, a video signal consists of one luminance and two chrominance. Luminance and chrominance we will see coming to in next topics. And coming to here in this video signal, the video signal which is going to comes to the luminance and chrominance is based on luminance and chrominance signals. So coming to here in this, especially these signals is going to be depend on video bandwidth. Is going to depend on video bandwidth. So this video bandwidth which is computed as follows. So coming to here 700 by 2. So here 700 by 2 one method is there. So the method comes to the 700 by 2 pixels per line into 525 lines per picture into 30 pictures per second. So like this is the formula we have to use to calculate the video bandwidth. So whenever you are going to give this pro forma, you are going to be get the video bandwidth. And next one comes to the visible number of lines comes to the 480. Next one, intermediate delay. So between, especially in video, whatever may the frames will be there. So in these frames we are going to be get intermediate delay. So in this intermediate delay, the frames are comes to the 1000 milliseconds divided with 30 fp, 30 frames per second, fps. So frames per second we can call as fps. fps stands for frames per second, so which we can call as the total result comes to the 33.3 milliseconds. Display time per line is 33.3 milliseconds divided by 525 lines equal to 63.4 microseconds. So here comes to the display time. So per line comes to the 33.3 milliseconds, which is divided by 525 lines, which is equal to 63.4 microseconds, which is going to be taken 63.4 microseconds. The transmitted signal is a composite signal. So here the signal which is going to be consists of 4.2 megahertz. So whatever may the composite signal we are going to be taken, so which is going to be consists of 4.2 megahertz, and in this I am going to be taking the basic signal and 5 megahertz for the colors and intensity synchronization information I am going to take. So especially we have to be take 4.2 megahertz for the basic signal, and these are the signal part we have to be take for video transmission part. Next, color encoding. So generally the color encoding is going to be done by the video camera. So in this video camera it is going to be creates the three signals. So the three signals are comes to the RGB. RGB comes we can call as red, green, blue. So here whatever may be the scene and everything you are going to be observing here is going to be comes to the very natural. So why I am going to be getting this output in natural? Why? Because so in display properties I am going to be having this part. So what is the part I am going to be having? That means I installed with this graphics. So based on the graphics I am going to be getting the best output here. So this is naturally if you are going to be watch the images or anything, so which we can call as RGB color mode. RGB color mode we can call as red, green and blue. Next, especially for transmission the visual signal, it is going to be take the three signal. So especially the visual, that means the video signal is going to be take the three signals. First one comes to the luminance, which we can take it as brightness basic signal. So if the signal is going to be contains the brightness basic signal, that we can call as luminance signal. And number two is going to be called chrominance. So chrominance, which is going to be comes to the color signals. Number two, chrominance is going to comes to the color signals. Next, in NTSC, so generally we are going to be having the two types of color schemas are available. The two types of color schemas we can call as NTSC and PAL. So present we are going to be using the NTSC, and the PAL which we are going to be used in olden days. And coming to here in this NTSC, I am going to be taking the concept. So in this NTSC, the color encoding format which is going to be taken in natural way, and it is going to be gives the best output for us. So next one comes to the goal at receiver. So coming to here which we are going to be having the separate luminance. In this luminance I am going to be taking the chrominance components. So in this chrominance components I am going to be avoid interference. So it is going to be recover the primary color signals. The primary color signals which we can call as RGB signals. So here you are going to see the what are the different signals are available, especially in video transmission. So coming to here RGB signal. So this is for separate signal coding. So RGB is a separate signal coding which we can use, and here RGB is going to be consists three separate signals. So RGB is going to contain three separate signals, and in this it is going to comes to the red color, green color and blue colors. So other colors are coded, but primary color we are going to be take it as RGB only. So which RGB comes to the, which can call as 1. This color we can call as a neutral white color. So that's why, so most probably our images, whether that is photograph images or videograph, for both probably we are going to be take the RGB color mode only. Why? Because in this RGB color mode only we are going to be get the best output here. Next one comes to the YUV signal. So YUV signal is going to be depend on luminance. YUV signal is going to depend on luminance. So whenever is going to be depend on luminance, is going to be take it on brightness. So brightness component which is going to comes in Y format. So in this Y format, which I am going to be take the signal comes to the, I am going to be taking has U and V. I am going to be taking the color combination comes to the U and V. So if you are going to be observe the U and V, I am going to be taking the concept here. So what is the concept here? So here in this I am going to be taking the data. So what type of data I have to be observed? So especially in this I am going to be taking the data, and that data comes to the this way, and in this data I am going to be observe such things. So whenever you are going to be observe such things, especially, so here the signals is going to be based on U and V. So the signals is going to be based on U and V, and here comes to the Y equal to 0.3 plus R. So especially the signals, YUV signal is going to be having the such a bandwidth limit, and this bandwidth limit we have to be take, and in this bandwidth I am going to be taking. So Y equal to 0.3 plus R plus 0.59 plus G 0.11 B. So here comes to the signal 0.3, which is going to be consists of red color, 0.59 consists of green color, 0.11 consists of blue color. So this is comes to the red, green, blue. Next U comes to the B minus Y into 0.4 minus 3. So blue minus component I am going to taking Y. So which is multiply into 0.493, you will get U signal. Next comes to the V. V comes to the R minus Y into 0.877. So this comes to the, it is going to be gives the V value. So like this we have to be calculate YUV value. So based on that, whatever may be the output we are going to be get, that output we can call as the resolution of the luminance component, which is going to be important then U comma V. And in this coding ratio comes to the Y comma U comma V comes to the 4:2, 2:2. So this is comes to the YUV signal part. Next one more signal is there that we can call as YIQ signal. So in this YIQ signal is similar to YUV. So this is going to be used by NTSC format. So NTSC which we are going to be used for to play the best video formats. So especially in video formats we are going to be take the NTSC format only. Next one comes to the YUV. So YUV comes to the, here the calculation comes to the 0.3 red plus 0.59 green plus 0.11 of blue color. Next U comes to the 0.60 red minus 0.28 green color plus 0.32 blue color. Next V equal to 0.21 red color minus 0.52 green color plus 0.31 blue color. And these things we have to be observed. And this is comes to the, we can call as YUV, and this YUV which is going to become in YIQ signal part. Next one comes to the composite signal. So what is the composite signal? All information is composed in one signal. So whenever the whatever may be the video information, if you able to send or you are going to be composed if you want to send into one signal, that we can call as the composite signal. And in this I am going to be decode. So what is meant by decode? So once the video will be there, again if you are going to be make the one more process operation, that process operation we can call as the decode. In this decode we need the modulation methods. So in this modulation methods I am going to be eliminate interference between luminance and chrominance components. So in this I am going to be take luminance and chrominance components I am going to be take. Next comes to the digitization. So what is the digitization? Digitization comes to the before a picture or motion video can be processed by a computer or transmitted over a computer network. So what is meant by digitization? Digitization comes to the before a picture. So here I am going to be taking a picture, and in this picture or I am going to be taking the motion video, and this motion video can be processed by a computer or transmitted over a computer network. It need to be converted analog to digital representation. So I already told in yesterday class we are having the two types of videos. So what are the two types of videos? We are going to be having the, especially if you are going to be observe the videos, we are going to be having the analog video and digital video. Now the present we are using the digital format only. So in this digital format we are going to be store the video in the form of zeros and ones. Coming to here analog, which is going to be recorded in real format. So while taking the real format to digital process, the conversion which we can call as a digitization. This digitization we need to be converted from analog to digital representation. So like this I am going to be take the concept here to be converted from analog to digital representation. Digitization is the representation of an object, image, sound, document or a signal. So digitization comes to the which is the representation of the object. So coming to here, whatever may be in analog will be there, every object, image, sound and document on a signal. So which I am going to be take the analog signal. So I am going to be take by the discrete set of its points. So I am going to get by a discrete set of its points, or I am going to be taking the samples here. Next one comes to the digitization. Digitization equal to sampling plus quantization. So here the digitization I am going to be take the sampling part, and after the sampling I am going to be take the quantization. So these two I have to be observed. Next, sampling is the reduction of continuous signal to a discrete signal. So here coming to here the sampling is there, I am going to be take the reduction. So in this reduction I am going to be take the continuous signal. So in this continuous signal is going to be based on a discrete signal. So this discrete signal I am going to be take here. Next, refers to sampling the gray color level in the picture at mxn array points. So here sampling the gray color, I am going to take the one level of the picture at mxn array points will be there. So we have to initialize the image in array points, and whenever we are going to initialize array points, we are going to take the gray color, and we have to convert into from this gray color to RGB color. Once points are sampled, only they are quantized into pixels. So here we have to be convert the image and everything digitalization. So I am going to be quantization. So in this quantization in analog it is going to be have the points, and the quantization it can be converted into the pixels part. Next, sampled values is mapped into an integer. So whatever the values which we are going to be take in the form of samples, so it is going to be take in the form of the integer. Next, quantization level is dependent on number of bits used to represent resulting integer. So here the whatever number of bits are there, it is going to be represented in the resulting part of the integer. Next comes to the 8 bits. I am going to take in the 8 bits per pixel, and or you can take the 24 bits per signal. So whenever you are going to be take these signals, is going to be take the different types of pixels. So in these pixels it is going to be take the video data, and in this video data it is going to be take the concept which is going to comes to the output here. Next, need to create motion when digitizing video. So here we are going to be take the motion part. So here I am going to be taking the digitizing video. So digitize picture in time. So I am going to be taking the digitalize picture every time. So when we are going to be, I am going to be making digitalize, I am going to be taking the sequence of digital images, and which is going to be take the, so per second how many images I want to approximately I am going to be take, and after that analog motion video is going to be come. So this is comes to the your digitalization. So whenever the digitalization is going to become, the video is going to become in your system, and whenever the system is going to become, so next we have to give the video format. So in digitalization, especially the video, we can make conversion, and we are having lot of tools, and by using these softwares and tools you are able to convert videos in one format to another format very easy. Next, now I am going to be taking the video formats. So what is a video format? So video format we can take in computer form. So whenever you are going to be take the in computer, the video format is going to be depend on the input and output device. So these input devices and output devices is going to be take the video medium. So based on that video medium only, we have to give the format as the input, and after that you are going to get the output device very easily. So for this point we are going to be get the motion video medium, we are going to get very easily. Next, current video digitizers. So in this I am going to be taking the current video digitizers. So here in this I am going to be taking the digital image. So in this digital image I am going to be taking the frame. So this frame we can call as the digital image resolution, and after that I am going to be taking the quantization. So after that I am going to be take the frame rate. So that is comes to the in for 1 second or 1 minute how much frames we want is that we are going to be take. So especially the frames we are going to be take based on seconds only. So here we are going to take frames per second. So here in this I am going to defer digital image resolution, and these things is going to be depend on based on the frames per second. Next, the output of the digitalized motion video depends on the display device. So whatever may be the video depends how it is going to be play is going to be depend on display device. For example, you are given the high quality video, but you are having the very small resolution video. Is it possible? No, it is not possible. So for that part on video display device, how much the video display device is there, so that display device we have to be compute, and based on that video height and width only we have to be compute the video, and we have to be describe the video part on that. So here in this I have to be take the much often. So here I am going to be taking this much often is going to be used. So here I am going to be taking the much often. So here I am going to be using the displays and raster displays, and this display and raster display is going to be store the primitives, which is going to be store the display primitives, so which is going to be comes in a refresh buffer in terms, so it is going to be primitive in a refresh buffer in terms of their which is going to comes in terms of the refresh buffer. So like this I am going to be take the refresh buffer, and here I am going to be take the component pixels. So this is the thing I have to be observed, especially in a computer video format. So for this I am going to be taking the CPU, which we can call as a central processing unit, and next peripheral devices will be there, and these peripheral devices which we can call as input devices and output devices. Next it is going to be take the surface memory or frame buffer, and after that it is going to be depend on video controller, and this video controller output is going to be depend on monitor only. So this is comes to the, we are going to be take the computer video format, comes to the surface memory, next comes to the frame buffer, video control. So these are the things you have to be observed, especially is going to be take the video format, and after that the video controller display the image stored in the frame buffer. So especially the video controller will be there, and this video controller of monitor is going to be display the image. So especially it is going to be buffer. So buffer means it is going to be take the allocation. So just if you are going to be observe, when you are going to be watch the videos on your smartphone, the buffer will be done. So what is mean by buffer? On your smartphone resolution, the video is going to be take, and it is going to display the image stored, and it's going to comes to the buffer, and like that it is going to be access the memory, and next through it is having a separate access port will be there, and in this separate access port which is going to be take the scan rate dictates. So this is comes to the video controller is going to display the image which is going to be stored in frame buffer. And next, the constant refresh of the display is most important task. So especially if you are going to be observe the images, so you have to be observe the constant refresh. So whenever you are going to be observe the constant refresh, the display which is going to be comes to the important task. So in this it is going to be distribute the flicker effect, and the video controller is going to be take the buffer, and it is going to be taken by the timely which is going to be takes the 60 times per second. So here sometimes the video controller standard is going to be taken, and which is going to be takes the or supports different resolution and color presentation. So especially if you are going to be take the UHD TVs, which is going to be take the different resolution. So now it is won't take the normal resolution, it is going to be take the best resolution. The best resolution comes to the picture height, and based on picture height and width it's going to be depend. Now especially we are going to be using the 4K. The 4K video content which is going to be comes to the height and width. Height comes to the 3840 into 2160 width resolution will be there. So these things we have to be observed, especially in this part. So in this computer video controller standards are there. So in this I am going to be support the systems, so which is going to comes to the resolution and color presentation is going to be taken, and this is comes to the your video resolution. So this resolution we have to be implemented in our thing. So next one comes to the this continuation will be there. So we will discuss in the next class. Until then, take care and bye.